our Applied Data Science. I am Minh Thành Dương. Today I will talk about my assignment. The first question is what are the dimensions of chain image and chain labels, chain test and chain test label. So first of all, I will import the Kira's dataset and import the function MNIST to how the data to put into the train image, train label, and test image and test label here. I will load the data using the load data to show the dimensions of the train image. I will the command NDAM, so it will show the dimension of the train image. So the data dimension is 3. Same thing I use for train labels. So the train labels dimension is 1. Also test images dimensions is 3. Then the second question, what are the lengths of the chain labels and test label? So I use length function here, so it shows 60,000. Also the same one for test label is 10,000, and show some train and test labels. So I will pick some randomly train label and test label to show here, and I choose the first one, the index 0 to show. So the train label is the number 9 and the test label is number 92. Also I do something to pick numbers, the second train labels, also the third train label to show here. Question number 4, show the digital contents of the image of the index number 5, changing of the datasets. So I need to create a variable named digits, and it will contain the train images, the index 5. So this is the content, the label content. Next, the question is plot the image of index number 5. I will import the matplot library pilot to show the image. Then I use the imshow function. I put the data content I get up above here, and then I put show to show the picture. So I can see here is the pull over. And next I will the same thing for index 500 in the testing dataset. I use the same thing, like I create a digit and contain the test images, and then check up number 500. I show the digits here. This is the table of digits. Next thing, I will plot the images, and you can see it's the pull over. So import the model and layers. So I use from Kira's import models and from Kira import layers. Define a sequential model and call it my network. So first thing, I need to create my network variable, and this will equal the models dot sequential, and then I will reshape the train images from 28 to one column with 784 neurons. The first method, I use the reshape. The second method, I will use the flatten from the Kira layers. And this one is from the 20 minutes video. Next, I use to normalize the image by dividing the image by 255. So the first method I use is divide by 255, and the second method I use utils normalize from tensor keras. Next, add one hidden layer with the has 512 neurons using relief activation function. So from the book, I write the code here, my network dot add. So it will add the layers, and the dense here, like how many neurons do we need for the layer. So it's 512, and the activation here really rave, and the input shape with 28 times 28. Next, I will add another layers, but this one only have 128 neurons, and I use this one also the same one. Add layers, then 128 activation relief. Next, add the last layer, like the output layer, is how 10 neurons, and activation is soft marks. So basically, this one is have the 10. It will return the array of 10, and for it's the sum of 10 it is 1, and it will show the 10 probability that the current digit image belong to one of our 10 digits classes, and so it will show the what the most like the most suitable image from the active the output, one in the 10 output. So some of them totally is 1. Next, number 17. So we have two settings for compiler we can use, and for the first setting I will optimizer name Adam, and the loss function is sparse, categorical, cross entropy, and the matrix I use accuracy. So for the first compiler I just use fit the trend image, trend label, epoch is 10, so it show the data here. And for I will count the test loss and the test accuracy using evaluate, so it will calculate for me here, and I will bring the test accuracy here so that it's 0.88. Next, so for question has is overfitting, so because the difference between 0.8 here and 0.9 here, so they have the difference between the training test and the testing output, so they have the overfitting. For the second setting, this will use the optimizer rmprob, and the loss function is the categorical cross entropy, and this one need to categorical the trend label and the test label. Next, I use the fit one to train the network, and it has the 10 epochs too, and the size of this one is 128. So this one I also the same thing for evaluate the accuracy. So this you see here they have difference between 0.9 and 0.868, so also they have the overfitting too. So that's it in my assignment. Thank you for listening.